Hope so. All right, so we finished these up yesterday, so we're on 22. So 22, there are some, like it, where the denominators aren't already the same. So the first thing we need to do is make them be the same. And to do that, we need to factor the denominators as completely as possible. Now, x plus 7 is factored as simplified as it gets. So we can't do anything to it. But the x squared plus 5x minus 14 can't be factored. Since the 14 is negative, our signs are opposite, positive and negative. Factors of x, 2 and 7, and the 7 would be positive. So we'd have x and x, 7 and 2, and we get this here. Now that we have both of them factored, we can start with the one on the right, see what we need to multiply it by. So we're going to see what is it missing that the one on the left has. X minus 2. And that's the only thing we need to multiply it by. Now we can go the other way. We can see what does the one on the left have, or what is the one on the left missing that the one on the right has. Yeah, so the one on the left had the x minus 2, so we need to add it to the one on the right. The one on the right, well, everything it has, it's already done. There's nothing we need to add to this one here that this one doesn't already have. They're good. So it's not always going to be the case that we have to multiply both fractions by something. Because here, we only had to multiply the one on the right by x minus 2 on top and bottom. Because the one on the left, our x squared over 7x, not 7x, x plus 7 over x minus 2 is fine as it is. Now the one on the right, we do need to distribute the numerator, but the denominator is still just going to be x plus 7 times x minus 2. And we multiply out the numerator, x times x is going to be x squared. X times negative 2 is negative 2x. 3 times x is plus 3x, and 3 times negative 2 is negative 6. Now at this point here, we can combine like terms in our second numerator. Plus 7, well, for a little bit x minus 2. So our numerator of our second will have x squared, negative 2x plus 3x is going to be plus x minus 6. So we combine like terms. And once we have everything simplified in the two numerators, we can go on and subtract. So that means for us here that we do have x squared minus 5 minus x squared plus x minus 6. Now when we subtract, we do need to make sure we distribute that negative through that entire set of parentheses, that second numerator. The x squared minus 5 is still going to stay x squared minus 5. But the x squared is now negative x squared. Our middle x term is now negative x. And the negative 6 is now positive 6. So we had to distribute that negative through those three terms. Now at this point here, we can combine like terms. X squared minus x squared is 0. Negative x is our only x term, so it's just going to be negative x. And lastly, negative 5 plus 6 is plus 1. Now this is our final answer, because there's no way to factor the negative x plus 1. We can factor a negative out of negative 1 out of the two numerators, our negative x and 1, but that won't really help us, because we'd get negative times x minus 1 over x plus 7 times x minus 2, But even if we have this, there's nothing in common on top and bottom that would simplify. So this is as simplified as it gets. Any questions over this here? We good with these here with addition, subtraction? The next thing I want to look at is least common multiple. Least common multiple is really setting and seeing what is the first expression that we can make each of the individual expressions be the same. That's really what we're looking for. So if we look at 26, 2x squared is simplified as it gets. Because when we look at least common multiple, we need to factor them completely before we find the least common multiple. 2x squared is as simplified as it gets. Now 4x plus 12 has a greatest common factor of 4. And if we factor it out, we get 4 times x plus 3. So least common multiple, we're trying to see what is the first expression that we can make 2x squared and 4 times x plus 3 be. Now in either case, we're going to need the x plus 3. Which means now we're looking at the 4 and 2x squared because they're individual terms. Well, the first number we can turn both 2 and 4 into is 4, but we'll also need what? The x squared. So this is just 4x squared times x plus 3. That would be the least common multiple. Any questions on 26? Let's look at 28. Now 28, we still need to factor the x squared minus 2x minus 63. So if we factor this here, there is no greatest common factor to pull out. So we can use our 2 sets of parentheses with 3 spaces. Since the 63 is negative, our signs would be opposite. One's going to be positive, one is going to be negative. Now our factors of x squared are x and x. And now we need to look at the factors of 63. 6 and 6 is 36. We'd have 1 and 63. 2 won't work, but we have 3 and 21. And then, what is it, 7 and 9? I think is the next one that works, and that's actually the one we need. The 9 would be, and the 7 would be positive. Now, when it's just parentheses, sets of parentheses are these binomial terms, I normally just grab everything from one of them. So I grab the 2 from the x squared minus 2x minus 63, and then I look at the other one and see what does it have that it doesn't. It only has one x plus 7, so x squared minus 2x minus 63 was the least common multiple. And that's it. Questions on any of this here? Do we need to see another example of one of these with 27 or 29? Sure. 30 won't show up. 30 is just saying what is the least common multiple between those 3 terms. So you're not actually solving anything for that there. And this would just be 3 times 2x minus 1 times x plus 9. It would just be the 3 denominators. If we looked at 29, between 4x squared and 16, they have a greatest common factor of 4, which we would factor out, leaving us with x squared minus 4. Now x squared minus 4 is a difference of perfect squares, and it would factor to x minus 2 times x plus 2. questions on this so far? Now our other one, 6x squared minus 24x plus 24 is the greatest common factor of. And if we factor it out, we have x squared minus 4x plus 4. Now x squared minus 4x plus 4 will factor. Since the 4 is positive, our signs are the same and match the sign of the middle term. So we'd have negative and negative. The factors of x squared are x and x, and the factors of 4 that we want are 2 and 2. Least common multiple. Well, we can grab 2 of them from one of these. I can say x minus 2 and x plus 2. Is there anything else the other one has that the first one doesn't? X minus 2. Since this one has 2 of them, the least common multiple is going to need 2 of them.
Oh, I remember
Yep. And the last thing is we need to see what is the first number I can turn both 4 and 6 into. 12 going up. So that there's the least common multiple. 12 times x minus 2 times x plus 2 times x minus 2. Yep. Any other questions on this here? Solving, this is the last thing we're going to look at on the review sheet, is solving these rational expressions. Now, the first thing we need to do, especially with this here, is multiply both fractions by something that will make the denominators cancel. So I can multiply both sides by x plus 6. Because the one on the right, the x plus 6, will cancel with its denominator. And we'll also need to multiply both of them by 2x. Because that'll make the denominator on the left cancel out. Now what that leaves us with is 4 times x plus 6 is equal to 5 times 2x. Now we can distribute. 4 times x is 4x, plus 4 times 6 is 24. 5 times 2x is 10x. Now at this point here, we can get the x's by themselves, so we can subtract 4x from both sides, telling us that 24 is equal to divided by 6. 4 equals x, or x is equal to 4. Either way, same answer. Now we don't have to worry about restrictions for this here, mainly because the restrictions are 0 and negative 6. 4 is not one of those two. On the test, I will specifically say when the restrictions are going to be coming in. It will have a note in the directions. Got to watch out for restrictions, those there, just so you're aware of which ones you do need to pay attention for those on. Not that the rest don't have restrictions or some to pay attention to. It's just they won't come up as solutions. Hopefully save you all a little time so you're not having to check every single one. Now let's look at 32. Now with these here also, we do need to simplify the denominators, factor the denominators if we can, so we're not using more factors than we absolutely need. Because x minus 3 is factored as completely as possible. Now we need to see if we can factor x squared minus 27. Now this here could be a difference of perfect squares, because x squared is x times x. We just need to see what times itself is 27. We can take the square root of 27 and we get 3 square root of 3. Is that a perfect square? Because we need this to be a number without a radical. So it's not a perfect square. If it had been 9, because x squared minus 9 is a difference of perfect squares, it's x minus 3 times x plus 3. So that tells us that x squared minus 27 is not a difference of perfect squares, so it won't factor. So all that means is one thing we have to multiply both sides by is x squared minus 27. Because it'll cause these two to cancel. And we'll also have to multiply both sides by x minus 3, which these will cancel. And what that leaves us with is negative x squared minus 27 is equal to x minus 4 times x minus 3. Now for the first one, we can distribute the negative, telling us that we have negative x squared plus 27. On the other side, we can multiply this out. X times x is x squared minus 3x. Distribute the negative 4. Negative 4x, and negative 4 times negative 3 is plus 12. Now at this point here, we can combine like terms. X squared plus 27 is equal to x squared minus 7x plus 12. Now that we have all the like terms combined, we need to get it equal to 0. So one of the things we can do is add x squared to both sides. We could also subtract 27. Because that will make the left side of the equation simplify to 0. X squared plus x squared is 2x squared minus 7x minus 15. Now for this here, we could try to graph 2x squared minus 7x minus 15 in the graphing calculator and see if we do get two solutions, and we will. However, one of them is going to be fractional. Because if there was a greatest common factor of 2, we could have factored it out. But unfortunately, we can't. Now, since the 15 is negative, our signs are opposite. Factors of 2x squared, well, we will have x and x, 2 and 1. Now, since we know that the middle term is negative, I put the 2x with the plus, because when we distribute this out, the 2 is going to multiply with the negative number, hopefully giving us a bigger negative number. Now 15, factors are 1 and 15, or 3 and 5. Again, we want a bigger middle negative number. So we can put the 5 with the negative, 3 with the positive. And if we check this here, 2x times negative 5 is negative 10x. That is not a great color. Negative 10x. 3 times x is going to be plus 3x, which does indeed give us the negative 7x that we want. Now the last thing we need to do is set both of these equal to 0 and solve. So we have 2x plus 3 is equal to 0, and x minus 5 is equal to 0. So the first thing we can do is subtract 3 from both sides, telling us that 2x is equal to negative 3. Then we can divide both sides by 2, telling us x is negative 3/2. And over here we can add 5 to both sides, telling us x is 5. And that's it. Now, neither one of these are our restrictions, because if we were looking at restrictions, x could not be 3 for our x minus 3. And it does work out that the other one is going to be plus or minus 3 roots of 3. And we definitely did not get 3 roots of 3, 3 square root of 3, positive or negative, as our solution. So these here are our two solutions. Questions on any of this here? I think we feel pretty comfortable, especially when we have one fraction on either side. Now, 34 is the next one we'll look at. Now, before we go multiplying through, so this here, I'll tell you ahead of time, won't have any it does have restrictions, but they won't be part of our solutions. We won't have extraneous solutions for this one here. However, we do need to make sure to factor all the denominators as far as possible before we start multiplying through. And I say that because if we did leave this as x squared plus 1 and multiplied everything through by x squared minus 1 and x plus 1, I would not write this down, it's going to cause not too many issues, but it's going to make the problem harder to work. As this here, the x plus 1 and x plus 1 cancels. X plus squared minus 1, x squared minus 1 cancels, and we're left with this here. Now what that's telling us is that we have 4x plus 1 times x squared plus 1. And just this here is going to be 4x cubed plus 4x plus x squared plus 1. We're dealing with a cubic. I wouldn't write this down. Just a heads up. Yes, okay. Because we're dealing with a cubic here. Here we're going to have 12x plus 12 plus 3 times, and this is going to end up being x squared, not x squared, x cubed plus x squared minus x minus 1. So we're dealing with a lot of bigger powers. And the reason I say that, and this is not going to be helpful, is we will end up getting this correct answer, but we're having to deal with cubics. I'm going to erase all of this here. Because if we factor x squared minus 1, what does it factor to? X plus 1 times x minus 1, yes? So, when I was multiplying by x squared minus 1 and x plus 1, I was actually multiplying it by what? X plus 1 times x minus 1 times x plus 1. I was multiplying it by x plus 1 twice, not once, even though we only needed it one time. And what that'll do is when we get, as you saw, we were dealing with cubes. That's not as nice. Now if we just multiply by just x plus 1, x minus 1, because that's really all we need, here, the x minus, not x minus, x plus 1 and x plus 1 will cancel. In the middle, the x plus 1 and x minus 1 will cancel with both. Really going to cancel it out. And the last one stays the same. So our first one here, 4x plus 1 times x minus 1. The middle one is just 12 plus 3 times. Well, we can already see so far this is a lot nicer than the previous one. Because even though we haven't multiplied anything yet, the middle term, 12, doesn't have an x minus 1 with it. That's nicer. Now over here, we have x plus 1 times x minus 1. There's two ways we can go about this. Let's wake up. Thank you. Yeah. Because we can do x plus 1 times x minus 1, but where did we get both of these from? Right here, yes? So if x plus 1 times x minus 1 factored from x squared minus 1, if I multiply them back together, I'm going to get back to x squared minus 1. Because we could go on and multiply them together and have it as x plus 1 times x minus 1. That's perfectly fine. Because when we multiply them back together, we will get x squared minus 1. So if we see that, oh, x plus 1, x minus 1 came from x squared minus 1, we can go on and just replace it. If we don't, multiply them together, we will get back to the same place. It's just saving a little work on ourselves. Now at this point here, we do need to distribute. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 1 times x is plus x, and 1 times 1 is negative 1. As we can see here, this is already simpler than what we had before. Would we agree with that? Because we don't have any cubes or any other answers like this. I'm just going to go on and combine those two like terms. On the other side, we're going to need to distribute the 3. So we'd have 3x squared minus 3. And we do have like terms on the other side. 12 minus 3 is 9. Now we do need to get it equal to 0. I'm going to move everything from the right side to the left, mainly because the x squared on the left is bigger. So we can subtract 3x squared from both sides. We can also subtract 9. All of that becomes 0. 4x squared minus 3x squared is x squared. Minus 3x minus 10. Now, since the x squared, there's a number, the number in front of it's 1, we could graph this if we wanted to. So I can take the graphing calculator and go on and graph it. X squared minus 3x minus 10, graph. It has two nice intersections, and if we look at the table, yep. So that just tells us the solutions are -2 and 5. I knew we were going to get nice integers since the number in front of x squared is 1. That means we're not going to have a division of that number. Because if we look back at 32, 2x squared, one of them is going to end up being divided by that 2, or the factors of the number in front of x squared. So we're going to have a fraction. Here, we don't have a number in front of x squared, so there's not that division, so most likely we'll get whole numbers. If we did factor it, it would have been x minus 5 times x plus 2 is 0, telling us x minus 5 is 0, or x plus 2 is 0, plus 5 minus 2. So x is equal to 5, or x is equal to -2. We get to the same answer, and that's it. Questions on any of this here? Be ready for the last one. We'll look at 36. Now 36 would be one that does have restrictions. It has restrictions, so we're on 36. We all there? Now, the restrictions are what values of x that will make the denominator be 0. Now we have 3 different places where it can be 0, but we're only going to have 2 values. One of the values that x cannot be is 3. 0 and 3. Because whenever x is by itself, there's no other numbers added or subtracted from it. It's just going to be 0. So our 1 over x, x cannot be 0. And for x minus 3, well, 3 minus 3 is 0, so x cannot be 3. And for some of these here, if we get something that's a little more complicated, we can just set it equal to 0, solve, and whatever the solutions are, for that are our restrictions. Now at this point here, we do need to multiply everything by x minus 3. Yes. We'll need x minus 3 and x. Because the first one here, the x minus 3 and x minus 3 would cancel. The middle one, the x and x would cancel. And the last one, the x minus 3 and x minus 3 would. Nope. Since it only appears once, we only need it once. Now, if one of these had, if it had two of them, we would need it twice. And one thing I find helpful, especially with this here, is okay, I see x minus 3. I'll multiply it all by once and go through and cancel them out individually and say, okay, are all the denominators simplified? This one has another one, so I need one more. Because it's easier to add them in or multiply them through in than it is to go backwards and say, oh, I added too many and try to pull them back out. Because most likely, once we go over what is necessary, we won't really see it until we actually multiply through, and everything looks way too big. So I normally do it kind of one at a time, making sure they all simplify. Now at this point here, what we have left in the first one is 2 times x plus 1 times x minus 3 is equal to x times x minus 1. Now, in one of the earlier hours, they asked, couldn't we have just written this as 2x? Well, yeah, that's perfectly fine. The x minus 3, we didn't necessarily need the parentheses because the sign in front of it was plus, so it's not really changing the signs. If it had been a minus, our middle fraction, then we would need to distribute the negative, but that's not the case here. And lastly, we distribute the x. X times x is x squared. X times negative 1 is negative x. Now we can combine like terms. 2x plus x is 3x minus 3 is equal to x squared minus x. Need to get it equal to 0 so we can minus 3x from both sides and add 3. This entire side is 0. The other side will have x squared. Negative x minus 3x is negative x plus 3. Well, there's two ways we can go about doing this. We can factor it. Since the 3 is positive, the signs are the same and they match the sign of the middle term, which would be minus, negative, and negative. Factors of x squared are 3 and 1 or 1 and 3, either way. Since we have two things multiplied together to equal 0, one of them must be so x is 1. Here we can add 3 to both sides, telling us x is equal to 3. 3. Yep. 3 is one of our restrictions, so x cannot be 3. It's our extraneous solution, meaning the only solution for this here is that x is equal to 1. And that's it. Any other questions on this here? All right. So that's the end of it. There are more examples, but I think with these here, we feel pretty good with it. So that is it for that there. If there's any assignments you have not done and gotten turned in, go on and work on those, get those turned in.